So chapter 9 is going to be all about measurements. Measurements. And really that's going to be, the metric system is among those. We should have a basic idea of how measurements work. We should have a basic idea. We are going to introduce one tool that is going to actually make your life a lot easier. Because sometimes you may not know, okay, I need to convert from inches to yards, or inches to feet, or feet to yards, or there's meters. You can put meters, kilometers. Sometimes it's difficult to know when we need to multiply by a number, when we need to divide, whenever it's time to make the conversion. We're going to learn something called dimensional analysis or unit analysis that breaks it down in terms of fractions. And we're going to see that the fractions aren't nearly as bad as we think. Plus, we're using a calculator. So using a calculator is much easier than the normal way. So some of the linear units of measure. And what do I mean by linear? I mean length, which is a one-dimensional measure of, well, kind of hard to say, but in this case, we could say a one-dimensional measure of how much something takes up physically. How much of the physical world does something kind of inhabit? And it can do so in 1, 2, or 3 dimensions. Now, we live truly in 3 dimensions, but when you're talking about length, you're just talking about one dimension. You're going one direction. Oh boy, there's a Harry Styles joke in there that I'm gonna not make. So some of our basic measurements, we actually, in America, we use the English system. So they also generally use this system in England. If you've ever watched like the Harry Potter movies, they actually say miles, they don't say kilometers, because we use the same system generally that they do in England, at least for length. So we know there's 12 inches in a foot, 3 feet in a yard, 36 inches end up being in a yard, if you think about it. And then a mile is famously 5,280 feet. But what we can do is we could use something called a unit fraction. We know there's 12 inches in a foot. So there's 2 what we call unit fractions we can use to express that. When I have it written like this, I can say 12 inches per 1 foot, which is true. The word per makes us think of division, which is what's going on. We can do 1 foot per 12 inches though. So we can take any unit fraction and flip it on its head depending on what we need to do. We can take 3 feet to 1 yard, 1 yard to 3 feet, 5,280 feet to 1 mile, or 1 mile per every 5,280 feet. It's really the way you want to orient the fraction depends on what you're trying to convert from. And you'll see what I mean here in a moment. So dimensional analysis is going to let us use our unit fractions, and just like you might cross things out in a fraction, you can actually cross out units themselves, and that's how we get away from certain units. For instance, if I wanted to do 40 inches and I wanted to convert that into feet, well, you might automatically know you need to divide by 12, but what if you didn't? What if you accidentally thought to multiply by 12? Well, that's possible, but let's look at how we can use unit fractions to avoid that kind of mistake. We know there's 40 inches, and then you can just say it's per 1 unit of nothing, but there's 40 inches. We want to go from inches to feet. So when we go back here and we can use either of these unit fractions, well, I know that I want to get rid of inches. So I need inches to be on the bottom, because then if inches are on the bottom, they'll cross out with some inches that are on top here. If one's on top, the other's got to be on bottom for it to cross out. That leaves feet on top. That means feet will be the only thing left, which is exactly what I want. That'll be the unit that stays after the dust is settled. And thus, with the way the fraction's oriented like this, I see 12 is on bottom. So I would do 40 divided by 12. My unit will be feet. And 40 divided by 12 can either be the fraction 3 1/3 or 3.333333 feet. However you want to say it. Or even 3 feet 4 inches. We want to convert 13,250 feet into miles. Well, I have a choice of 2 unit fractions I could use here, but I'm starting with feet. I want to end up with miles, so I want feet to be on the bottom so that the feet cross out. Boom, boom. And then the miles is on top, and that's what's going to end up staying because nothing's crossing out with miles. Once I do that, I know the 5,280 is on bottom, so I automatically know to divide by it. So this becomes 13,200 divided by 5,280. The miles stay put. You do the actual math, you go whip out your calculator, you'll get 2.5 miles. Exactly 2.5 miles. That's what I used to do on the elliptical at the gym. And then I can't go to the gym, and it makes me so sad. I used to love going to the gym. It was good. Now all I do is go to Mr. Jim's, which is a pizza place. I don't know if there's one nearby here. And also I haven't had it in years. So I don't do any of that. So this is these unit fractions are going to take us a long way. Now look, what I'm going to do on this next, on not exam 2, because exam 2 only covers chapter 8. Exam 3, though, is going to cover chapter 9 as well as a little bit of chapter 11. So for exam 3, you're going to actually have access to all of these conversions. In fact, actually, I'm just giving you the same formula sheet. So the formula sheet you'll use will have all these conversions on here. You have to know how to put them into a unit fraction yourself. Yes? You'll want to print it out. The way you access it is if you're on Canvas, there's the exam 2 module, and the exam formula sheet is going to be in there. It's a PDF. That's the formula sheet for all exams for this course. We didn't need one for exam 1. There were no formulas. And so there might be some extraneous stuff on that sheet that you don't need, but it at least has the formulas you do need. So you can convert things into unit fractions. Now, the most important thing maybe I can teach you. So we can use unit fractions. You can actually use unit fractions no matter what you're converting between. If you're starting with English measurements and going to another English measurement, miles to feet, inches, yards, you can use unit fractions. There's a cool little trick though. There's a cool little trick that you can use whenever you're doing metric conversions, In the metric system, we have some things called prefixes. A meter is the base unit of length in the metric system. A meter. A meter is a little bit, I think, more than 3 feet, just a little over 3 feet long. That's their base unit they use. That does not have a prefix on it. But then we can go up and we can say a decameter is 10 meters. A hectometer, which you probably won't use often in reality, a hectometer is 100 meters. And then a kilometer is 1,000 meters. And a kilometer for them is kind of how they measure long distances that people travel, like by car. Just like we use miles, they use kilometers, although 1 kilometer is not the same as a mile. So anywho, we do all this. We can use something called the King Henry Dyed system. And while perhaps a little bit morbid, I can show you how it works to help you memorize the prefixes. You say King, K for King, Henry, died, and then you're so sad because Henry died, King Henry died. Maybe you are a big fan of Henry VII, who overthrew Richard III in England, which was a tyrannical government. And so Henry VII established a new government and was also very frugal with his money. So maybe you're sad that Henry VII died. Maybe you're sad that his son, Henry VIII, died. And Henry VIII is a lot more famous. Henry VIII famously wanted to get divorced. The Catholic Church wouldn't grant him his divorce. So what did he do? Well, eventually he branched off of Catholicism and created kind of his own church, the Anglican Church, which kind of set up the modern Protestant movement, which most Christians in America are Protestant as opposed to Catholic. So that's kind of interesting. So Henry VIII, maybe you're sad that Henry VIII died. So you're going to sigh. You say, King Henry died, and you go, oh, and you sigh. And then you finish it off. How did he die? Well, he died drinking chocolate milk. So you can see that little acronym. A little bit morbid. I don't think he actually died from drinking chocolate milk. I mean, that wouldn't be a bad way to go, I guess, because chocolate milk is delicious. And so this is how we can, first of all, memorize the units. Second of all, we can tell ourselves, well, we can make metric conversions between these things. We can make conversions between these things. So this is how it's going to work, these conversions. First of all, you can remember King Henry died drinking chocolate milk on the side here. And what you're going to do is if you're starting with a larger unit and you want to convert down to a smaller unit. So if you started with like 1 kilometer, that's equal to 1,000 meters. And that's going to be a heck of a lot of millimeters. So if you're starting from a unit that seems larger and you're moving down, the units themselves are only going to expand, because in order for me to express 1,000 kilometers, I'm going to need a lot of millimeters, say. So kind of this box makes it a little confusing here, so let's ignore it just a little bit. Just think logically. If you went a kilometer, which is kind of like a mile is in Europe, if you went a kilometer, you went a heck of a lot of millimeters, because a millimeter is very, very, very tiny. So if you're moving from a larger unit to a smaller one, you're going to have to make them larger. You're going to have end up with larger numbers. So moving down, you move the decimal point 1 place to the right each time you move down. That's the beauty of the metric system, because the metric system is a base 10 system. So when I'm moving from kilometers to millimeters, I'm actually just multiplying by a power of 10. I'm multiplying by 1 million, and all that does is move things down. So that's why this King Henry died business is really useful for remembering this stuff. If you're moving up, if you're starting from like millimeters and moving up to meters or decameters, and you just don't give what's that word, DAM? You just don't give one of those. Then what you're going to do is you're actually, think about it. A millimeter is really, really tiny. If you only had like a millimeter of something, you barely have anything, which means you have even less kilometers, because a kilometer is a massive amount of space. So if you're starting off with a millimeter of something and trying to move up, it wouldn't seem appropriate to do that, but you could. You're going to end up with an even smaller number. It's kind of inverted from what you think. You start with a millimeter and move up to kilometer, your number is actually going to get smaller by factors of 10. But it actually makes sense, because a millimeter is so tiny, to express it in kilometers, you'd want an even tinier number, because kilometers are supposed to be large. So if you move up this bad boy, moving up, you move the decimal point one place to the left each space you move up. So if I move up from millimeters to decameters, that's 1, 2, 3, 4 places I moved up the chart. Thus, I would move the decimal point to the left 4 times, 4 total places. That's how I can convert from a metric unit into another metric unit. The cool thing is, this is true, we're using the metric unit for length, which is the meter, but it turns out there's other metric units. You can use a metric unit for volume, which is the liter, L-I-T-E-R. That's the metric unit for volume. The metric unit for what they call mass, which sometimes gets confused with weight, which are kind of similar. For mass, they use grams, but they use the exact same prefixes and the exact same rules for converting between them. So let's look at this. So we've already done that. Let's say you're starting with 504.7 kilometers, or just meters, excuse me. Well, okay, write out your King Henry died. This is how we're gonna do it. Let's see, King Henry died, always sigh because you're sad. That's where you're gonna put the base unit you're using. Drinking chocolate milk. The base unit is a meter. And in this case, we're going to have 504.7 meters, which is kind of a lot of space. That's not something I would want to, walk in just like a couple minutes. I'd have to run to do that. And I might not even be able to. So we have 504.7 meters. We want to convert it to kilometers, which is up here at the top. So we got to go 1, 2, 3 spaces up. So we're going to move the decimal point 3 places to the right because we're moving up the thing. And I'm sorry, we're moving it to the left, excuse me. So we take our 504.7. We move that 1, 2, 3 times to the left because we're moving up the thing. And what we end up with is 0.5047 km for kilometers, which makes sense. 504.7 meters, we don't need as large a number to express that length if we're talking about things in kilometers instead. So it just kind of is logical. Now, here they write the King Henry died from left to right, which is a good strategy. Look at how they do it. And so if you're starting with meters, you have to move 1, 2, 3 places to the left, and thus you're also going to be moving the decimal 3 places to the left. So that's another way to remember your King Henry died. But I just remembered it up and down from my school days. And again, this is based entirely off, if you're moving from a metric unit to another metric unit. You want to convert 27 meters to centimeters? You'd be moving down, or in this case, to the right. You're moving it to the right 2 units because you're going from a larger thing to a smaller thing, so you actually need more to express the same amount. So 27 meters, the decimal point would be at the end here. Move it 2 places to the right, it would be 2,700 centimeters. So centimeters and millimeters are pretty common units of measurement. Kilometers are pretty common, and then just meters themselves. You'll see that a lot. Hectometers, decameters, decimeters, you won't really see them as much. What's interesting, if you're talking about storage space on a computer, the base unit for storage space on a computer is a byte, B-Y-T-E. And then 1,000 bytes is actually 1 kilobyte. Now, secretly, it's actually 1,024. So we're being a tad bit sloppy when we just try to use metric prefixes, but technically we can do it and it's not that big a deal. So what you might notice is if I went 3 more places to the left, this is not all possible prefixes. If you thought it was, you might get hunted down by the prefix mafia. This is not all possible prefixes. If I were to go 3 more to the left, you would get to mega, just like there's megabytes. If I go another 3 to the left, I'd get to giga, just like gigabytes. 3 more to the left, I'd get to peta, P-E-T-A, not the animal rights group, but a petabyte would be 1,000, or technically 1,024 gigabytes. And then after that, I don't remember, just because you're not usually going to get that massive. What's interesting, though, is for computer storage, you don't go down. There's no centibytes or millibytes. It doesn't work like that. A byte is as small as it gets. Now, if you want to do conversions between the English system and the metric system, here's a couple of the basic conversions you might want to know. I don't memorize that 1 foot is 30.48 centimeters, but I do remember this one. This is classic. An inch is equal to 2.54 centimeters. A mile is equal to 1.6 kilometers, or 1.61 is more accurate. These two conversions here are exact. They're foolproof. These two are actually just approximate because the real number goes out a long way, so we just round it. Now, what you really need to know is if you're trying to make conversions, you can always use unit fractions. You really only want to use the King Henry dyed business when you're doing a conversion from a metric to another metric unit. Otherwise, you can use unit fractions, whether you're going from English to English or English to metric or vice versa. And remember, you're going to have access to the formula sheet. Let me just take a quick peek and we can look at the formula sheet. Oh, formula sheet. Let me downloadify it. And now let's take a look at it. Yes, you can see my Minecraft bookmarks. No, you cannot judge me for playing Minecraft despite being a 31-year-old man. I still call myself pretty cool. So here is some of the conversions you'll have on your formula sheet. Again, you're going to get this formula sheet on every exam going forward. You may not always need all the information. For this exam 2 that's on Thursday, you're only going to need these financial formulas here. These are going to be what you would need. For the exam after that, you'll need these conversions, and then you'll need some of these chapter 11 probability formulas as well. And then finally, for the final exam, you'll need the whole darn thing, won't you? So anyways, here's some of the conversions I give you. 5,280 feet is a mile. That means you yourself can convert that into the unit fraction, 5,280 feet per 1 mile. Or you can flip it on its head, 1 mile per every 5,280 feet, just depending on what you need. What unit you're trying to cross out, that's the unit you want to put on bottom when you're making your unit fractions. So you'll notice I give you 1 yard is about 0.9 meters. So a yard and a meter are almost the same. A mile is 1.6 kilometers. An inch is 2.54 centimeters. Yeah, you'll have all of these. So the converting between units is generally, I don't like the E word, easy, but it's generally pretty straightforward, I think. It's pretty straightforward. But we never use the E word. Suppose you want to convert 125 miles to kilometers. Well, go either on the formula chart or figure out what the conversion is. And bada bing, bada boom. Look, 1 mile is 1.6 kilometers. Since we're starting with miles, we actually want miles to be on bottom so that miles cross out. Goodbye, goodbye. We don't want it the other way where miles is on top. Thus, that means we know to multiply by 1.6 if we're going from miles to kilometers. And it's an especially useful way for deciding which way we should be multiplying or dividing. So 125 miles times 1.6 kilometers per 1 mile gives you 125 times 1.6, which is 200 kilometers. So 125 miles is 200 kilometers. So a single mile is longer than a kilometer. Not so bad when you use those unit fractions, downright pretty freaking good, if you ask me. And I would hope that you ask me, because I can tell you. Convert to 26,800 millimeters to inches. Well, look on your chart. Look on your charts. You're not going to have a direct unit conversion between millimeters and inches. I don't give you that. Why? Because you can use a go-between. You can convert 26,800 millimeters into centimeters. You'd have to go one space up If you think about your King Henry died, so you just got to move the decimal point one place to the left. So 26,800 millimeters is 2,680 centimeters. And the reason we converted to centimeters is because I know I will be giving you a conversion between centimeters and inches. And since centimeters is what's got to cross out, the unit fraction I'm going to use is 1 inch per 2.54 centimeters. So that centimeters go on bottom. I'm left with inches. Inches don't get crossed out. And I end up having to do 2,680 divided by 2.54. And I'll just round to the nearest inch. So that'll be 1,055 inches. Again, not so bad. As Dido once sang, it's not so bad, if you know that song. If you don't, that's okay. Most of you are under 30, so you probably don't know that song. I am not under 30, therefore I know that song. You gotta be like 30 to 45 to know that song. That was the era when you were like a teenager or a young 20s listening to music. Okay, so that covers the first section of chapter 9. So we're just talking about measurements at the end of the day. These are important to us. It's important for us to be able to measure the world. And heck, I haven't even gotten into some of the really interesting philosophical theory behind measurements. I have not done that. And we won't do that because it's just beyond the scope of the course. And you're like, Josh, we're already packing in a lot of math here. Ooh, Nelly, let's not go above and beyond. So now, length was our one-dimensional measure, basically of how much space something takes up, or just how much of something exists in the physical world around you. Length is a one-dimensional measure. We're going to use area. Area is our two-dimensional measure for how much space something takes up, physical space, not theoretical nonsense, physical space something takes up in 2 dimensions. And when I say 2 dimensions, I mean there has to now be 2 different measurements of length that are coming together to form area. That's what I mean by that. So in general, you're going to have, you can talk about squares. And what we can say is that a single 1 unit by 1 unit square is 1 square unit. It's kind of confusing, but an inch by an inch long square. We're going to call that a square inch. That's exactly what that means. It's an inch on each side. You can also have a square centimeter, in this case, a centimeter along each side. So check this region out. Check out this rectangular region here. We see that we can fit exactly, well, 3 times 4 is 12. We can fit 12 square units in this. If it was inches, this would be 3 inches by 4 inches up here. So I'll write that out. Let's say this was 3 inches. This was 4 inches. We might already know to do just do 3 times 4 and you'll get 12 square inches. You might have already known to do that, but this is kind of a nice visual justification as to why. It's because, and I completely flipped them, I apologize. Perhaps it would be best if your math instructor knew how to count, yeah? Apologies. This is obviously 4 wide here and 3 tall, excuse me. But it's because you have 3 inches here, 4 inches here, and you can just see that's almost like the definition of multiplying. That's why we multiply the lengths of each side together. And the units themselves get squared. Think about if I did x times x, that would be x squared. Here I'm doing 3 inches times 4 inches. The inches multiply to each other and become inches squared, or square inches. So it's kind of interesting that unit analysis is complete like that. That kind of unit analysis is super-duper useful. So we're used to saying that 1 foot is equal to 12 inches, right? Is anyone going to disagree with me on that? 1 foot is 12 inches? No. But 1 square foot is actually 144 square inches. And that might give you a little bit of pause. You're like, what is that? You might pause for a second and say, well, how come 1 square foot is not equal to 12 square inches? But think about what happens. If you had a square that was 1 foot by 1 foot, and I'll zoom in here. If you had a square that was 1 foot by 1 foot, each of those individually has to be 12 inches long. So actually that same square is 12 inches by 12 inches, which in turn means that when I multiply them together, I end up with 144 square inches. Let that sink in. That's actually very important here. 1 square foot is actually 144 square inches. 1 square yard, which is 1 yard by 1 yard, you're tempted to say that's 3 square feet, but it's not, because that creates 3 feet by 3 feet, which actually translates into 9 square feet. What we'll see when we look at three-dimensional things, volume and stuff like that, we're going to see that actually 1 cubic foot translates to 12 times 12 times 12, whatever that is. I think it's 16,000 something or other, somewhere in that ballpark. It translates to a lot more than that. 1 cubic yard, which is in 3 dimensions, translates to 27 cubic feet, because 3 times 3 times 3 is 27. That is just pretty gosh darn interesting to me. I don't know if it's interesting to you, but what I want everyone to do out there, whether you're in the Zoomosphere or if you're in class here with me, I want you to either through telling the truth or just by lying and placating to me, I want you to say, Josh, that's very interesting. Go ahead. It's interesting. Everyone in the Zoomosphere, please. This is just like paying tribute to the king or something, you know. And I'm not the king like Elvis or anything, but you know, it is very interesting. Thank you, Xavier. Even if you're lying to me, it's important that it's said so that I know that you are my loyal subjects. No, I'm just kidding. You're not my subjects. In fact, I really don't think of us that way. I think of me as someone who is helping you along the way in your math journey. But at the end of the day, I'm just another adult who is teaching you something. Now, that doesn't mean you can just disrespect me and say mean things about me to me, because I have feelings too, you know. Okay, so anyways, that was weird. So a few conversions we can make. 1 square foot is not 12 square inches, it's 144 square inches. Now you have to be careful because you may not get some of these conversions on the formula sheet. If we look back at the formula sheet, which is this here on PDF, you notice there's some cubic things. So like cubic inches is a gallon, but I don't come out and say 144 square inches is equal to 1 square foot. You have to understand this process behind the scenes and how to make the conversions yourself. That's important. But anywho, we can look back. A square mile is equal to 640 acres, which I didn't even know that until now. So very cool. That is a very cool thing. I guess that makes sense. You know, most properties are anywhere from like a 20th of an acre to maybe a 1/4 of an acre in most neighborhoods. You want to go any larger than that, you're usually going to have to buy a little bit of land, a little bit outside of a major metropolitan area. Not always, but rule of thumb. I wanted to buy some land and I wanted to just kind of live in a shack in the middle of the land and build like a 40-foot wall or fence, just like a giant fence around my land with cameras. And I thought about doing that. I very seriously considered it because secretly deep down, I'm kind of like a goblin and I like to, you know, live alone in my cave and, you know, play video games and order Taco Bell on DoorDash. So we all have our little things. So here's some interesting ideas that we can bring into the mix. Besides Alaska, Wyoming is the least densely populated state. Wyoming is actually a pretty large state, but you may not know a ton of people that live in Wyoming. especially because Montana is like right next to Wyoming, and Montana is really cool. I've actually only been to Wyoming once. I bet you Wyoming has some amazing sites. I think Yellowstone is in Wyoming? Yeah, that's right. Yellowstone National Park. And I've been wanting to go there forever. So Wyoming just doesn't have a very large population at the end of the day for how large it is. The population of Wyoming, whenever this was taken, 2019, I think, was a little over 500,000. I mean, we have more people in Fort Worth than Wyoming does as a state. And Weatherford is, it's not that much more populated than Weatherford. Weatherford is not exactly a giant city or anything. So anyways, the population of Wyoming is 568,158. Its area is 97,814 square miles. The population density then is going to be taken as a ratio of the number of people divided by the amount of space in area terms that the state has to its name. So we take the population divided by the area, that's 568,158 people, divided by 97,814 square miles. If you use a calculator and you round to the nearest tenth, you'll see that there's about 5.8 people per square mile of area. That's not bad. A square mile is 640 acres. So, 5.8 people for 640 acres. That means that everybody actually would get a little more than 100 acres, right? 100 acres is a lot of land. Well, that's not quite how it works. Everybody can't afford to live on 100 acres by themselves, or even, well, that would just be by themselves. Who's going to, you're going to farm that land? There's a lot of reasons why we have to move to cities and stay closer, because there's just more things there. And the actual amount of space that you get is not nearly that large. So it just means there's a lot of open area and uncultivated area that either someone owns or maybe it's unowned, but it's not exactly area you're trying to live because there may not be a lot of resources there. So just some interesting ideas. Some metric equivalents for area: 1 square inch is going to be 6.5 square centimeters. How do I know? Because a square inch is 1 inch by 1 inch, but then that would be 2.54 centimeters by 2.54 centimeters. If I do 2.54 times 2.54, I get about 6.5. That's how a lot of these calculations are made. And then there's also a unit of measurement called a hectare. I think that's what's used in Europe, or is a lot more common in Europe. I have no idea why that's the case. But I guess you can use a hectare if you want, if you're bored. So let's think. A property in Italy is advertised at $545,000 for 6.8 hectares. So we're actually, in this problem, it wants to know what's the area of the property in acres. Well, we don't exactly care about the price tag here, the $545,000. We're going to ignore that. But what we are going to do is we're going to take 6.8 hectares. Now we want to convert from hectares to acres, so we should use this bottommost conversion. And we can make 2 unit fractions out of this. We could say 1 acre per 0.4 hectares, or we can go the other way, flip it on its head. 0.4 hectares per 1 acre. Which one should we use? Well, since we're starting with hectares and want to end up with acres, we need to use the unit fraction that has hectares on bottom, so that hectares cross out. That means then the 0.4 was down there with the hectares. So we're actually going to have to do 6.8 divided by 0.4, which actually makes it larger. You divide by a number between 0 and 1, you make your value larger. So 6.8 hectares is exactly 17 acres. So to put that in perspective, 17 acres is a good bit of land, especially for like one person or a small family. 17 acres is huge. It's huge. That's plenty of land to build your goblin fort, which is what my goal is. What's that? For only 545, that might just be the land itself and not like a nice chateau or anything built on the land. And even, I mean, that would be cheap. I bet you could get, it just depends on where you are. If you're in the middle of nowhere, $500,000 for 17 acres is probably reasonable, I would think. If you're closer to a major city, especially if you want to like run a business on there, and if you're in Italy, you might be thinking about a wine business. That's probably going to cost you millions of dollars. And especially, that's just the land. It may cost a heck of a lot more if there's a nice home built on it, which is usually what you're really buying or mostly wanting to buy. So there's just all kinds of factors. But yeah, $500,000 ain't bad. And let's not forget, $500,000 is a lot of money. That's a lot of money. It's not easy to come across $500,000. Then what we could do, okay, so we do take the price into account. We might calculate the price per acre. We're just interested in knowing how much an acre of land costs on average. For this particular purchase, we would take the price of the house, $545,000, or of the land, divide by 17 acres, and this costs you about $32,000 and some change per acre, which actually sounds about right in Texas if you're a little bit out in the country. Usually you can't get that, and that's for no house, remember, that's just for physical land. If there's a house on there, it can double, triple, quadruple, just depending on, how large or how nice the house is. So there's some interesting ideas here floating around, but you can make any conversion you want using unit fractions. If you had to convert from square inches to square centimeters, use this and say it's 1 square inch per 6.5 square centimeters. So you're going to be dividing by 6.5. Well, now let's make the leap to 3 dimensions. We're going from Super Mario World to Super Mario 64 here. The American dream indeed is to buy land and to be a goblin living on that land. Volume is our 3-dimensional measure of basically space, or of space / physical, well, space is the right word for it. It is our measure of physical space, finally in the 3 dimensions that we care about. That's what volume is. When you go to the gas station and you purchase some gasoline for perhaps your Honda Civic, well, first of all, if you're driving a Civic, you ain't got to purchase a lot, and it's going to last you quite a while. But your gasoline is pretty much, for all intents and purposes in America, is measured in gallons. So a gallon is actually, it turns out, going to be a 3-dimensional measure of space. Because you think about like a gas can, it's a 3-dimensional object. Most objects are 3-dimensional. If you fill that thing with gas, you're telling yourself, okay, I'm filling up a 3-dimensional space with something, gasoline in this case. So gallons are a measure of volume. You have to be careful because a gallon does not have a cube on it. A gallon doesn't have a cube on it. So for instance, in 3 dimensions, we can talk about a cubic foot. That would actually be 1,728 cubic inches. So I was off by a little bit because it'd be 12 by 12 by 12. We'd have to do 12 times 12 times 12. A cubic yard would be 3 times 3 times 3 feet, giving you 27 cubic feet. So now we're just in 3 dimensions. Everything would seem to, we would call it cubic, but then we make some special exceptions. A gallon is not, you just say gallon, you don't say gallons cubed. Gallons cubed would actually be a 9-dimensional measure, which is beyond the scope of anything in this course, beyond what I can picture in my head. So a gallon is already understood to be a 3-dimensional measure of something. And so now whenever we're measuring volume, we have 3 different dimensions we have to respect. So this thing here, and it's not easy to draw 3 dimensions. But as you can see, this would be a shape that is 2 by, this is 1, 2, 3. And then we would also need this measurement across the top would also be 3. So the total, if this is a cubic unit, and that could be a cubic inch, cubic centimeter, cubic foot, etc., this thing would have a volume of 3 times 2 times 3, which is 18. You'd have 18 cubic units for this thing. Because just think about how many of these would go into this shape over here. So lots of interesting ideas floating around. Now we can get into some of the more common things, and a good lot of these are included on your formula sheet for the exam. So we can go back to our classic baking units. 1 cup is 8 ounces. These are 3-dimensional measures of things. If you have a cup of flour, you're talking about a 3-dimensional amount of flour. You don't have an area of flour that's flat. You don't have a 1-dimensional measure, just a line of flour, and it would look like something else if it was the case. So you're talking about 3 dimensions inherently. But when we say a cup, it's implied already to be in 3 dimensions. We don't say a cubic cup or a cubic quart, which would be fun to say. So a cup is 8 ounces. 4 quarts in a gallon. 1 gallon is 128 ounces. A cup is 8 ounces. 8 fluid ounces, technically. So a fluid ounce is inherently a 3-dimensional measure. An ounce in general, though, is usually meant to be a measure of a weight. You say, this baby weighs 6 pounds, 3 ounces, or I don't know if that's a realistic number. But yeah, so you just have to know it's implied if you're talking about 3 dimensions, you're talking about something called a fluid ounce, which is not the same as measuring mass or weight. That would just be a regular ounce. But then 1 cubic yard is about 200 gallons. A cubic foot is about 7.48 gallons. So if you're filling the tank of your car and it's a 15-gallon tank, you're probably filling it with about 2 cubic feet worth of gas. 231 cubic inches is about 1 gallon. So we can make these kinds of measurements. We'll finish up this section after the break. So back to what we were talking about with volume, 3-dimensional measures of things. A swimming pool has a volume of 22,500 cubic feet. How many gallons of water does that hold? Well, it's clear we want to go from cubic feet to gallons. So we need to figure out which one we need to use properly. And we have one that goes straight between cubic feet and gallons. Awesome. We want the gallons to be on top and cubic feet to be on bottom because we want to go from cubic feet to gallons, and thus we want cubic feet to cross out, like so. And so we're going to end up doing 22,500 times 168,300 gallons. Which is actually pretty wild if you think about it. So that's a pretty normal swimming pool. Olympic swimming pools, I think, hold 4 times as much water, a standard Olympic swimming pool. To put that into perspective for you, it's said that an adult man should drink about 15.5 cups of water per day. Well, I know that 1 cup is about 8 fluid ounces. It turns out there's then going to be what, 16 cups in a gallon? 16 cups in a gallon. So in other words, a human man should drink about a gallon of water a day, according to this. Well, that's actually pretty wild. If you drink about a gallon of water a day, then you could go 168,300 days on the water in a swimming pool, assuming, of course, it was potable, which means you can drink it, which, of course, you can't drink the water in a swimming pool. It's treated with something. When I was a kid, it was treated with chlorine, so we could never open our eyes when we got out of the swimming pool. Our eyes would be stinging. But if an adult man, drinks about a gallon of water per day, let's just put this into perspective. The man could live off the water in the swimming pool for 461 years. You just take 168,300, divide by 365 days in a year. So the amount of water that goes into a swimming pool would provide a human being 460 years of lifetime of water. If you took, say, 5 human beings, divided 461 by 5, that would be over 80 years apiece. So 5 human beings could each have enough water for over 80 years, which is about what their lifetime would be on the high end on average. So it's just wild to think how much water goes into a swimming pool. It could supply the lifetime water necessary for 5 human beings. But you know what? Is that going to stop me from getting a swimming pool? I don't know. It might, because the water is expensive. It ain't cheap to maintain a swimming pool. But if you like it, get yourself a swimming pool. In the metric system, the units of volume, also capacity, is the liter, L-I-T-E-R. It's a little bit more than a quart. Most of us know liters because we go up to the Walmart. We know we're going to be doing a lot of gaming this weekend. So what do we get? We get 6.2 liters of Mountain Dew. Now, they used to have that blue Mountain Dew, which is, I don't remember, it tasted like candy. It was just liquid candy. And it was amazing. I loved it. They don't sell it anymore. It was incredible. They have that Code Red, but Code Red's kind of not great. Base Mountain Dew is not great either. The green kind, I don't like that at all. But the blue Mountain Dew was awesome. Voltage, that's correct. High voltage. Slater is correct. Yeah, that was awesome. I'm getting me 6.2 liters of Mountain Dew high voltage. I'm getting me 14 cc's pizzas, and I'm going to play video games all weekend. Man, that was college. That was college for me. What happens? 10 years go by. Responsibilities take away what you really want to do in your heart, which is drink Mountain Dew, eat cc's pizza, and play video games. So anywho, there's some interesting connections here. 1 cubic centimeter, which if you ever watched a doctor show or if you've ever worked in the medical field as a nurse, doctor, whatever, you'll hear, give me 20 cc's of whatever, stat. Give me 20 cc. I don't know what they have. Well, that's actually just a milliliter. So you're actually saying I need 20 milliliters, and that's a pretty normal dose of some kind of liquid medication. 1 decimeter cubed is equal to 1,000 cubic centimeters or 1 liter. So 1 liter is 1,000 cubic centimeters. We use a capital L for liter. And then 1 cubic meter is equal to 1 kiloliter, which is kind of cool. This is a 3-dimensional measure. It's 1 meter by 1 meter by 1 meter. This is also a 3-dimensional measure. It's a volume measure. It's 1,000 liters. So an aquarium has a volume of 36,000 cc's, cubic centimeters. How many liters of water does it hold? Well, we have a conversion. 1,000 cubic centimeter is equal to 1 liter. Since we're starting with cubic centimeters and we want to go into liters, we're going to make that unit fraction to have cubic centimeters on bottom so that cubic centimeters cross out. Then we have 36,000 divided by 1,000, which ends up being 36 liters. So pretty cool. You have to be careful because this isn't just, oh, move up or down the King Henry died thing. because here you have centimeters is your base unit, meter. Here liters is your base unit. They're not the same base unit. So you can't come here and just use a single instance of King Henry died. It ain't quite going to work like that. Finally, let's look at the last section of chapter 9. The last section. We're going to look at measuring weight and temperature. It's going to be our last two things we're measuring. Again, a lot of what we're learning in these sections should be, I wouldn't call it common sense because maybe it's not something everyone knows, but it is stuff that you've probably learned about many times, either in your previous educational experiences in school or in the real world, if you will, or if you've done some baking, you've had to make conversions between different measurements in order to be able to bake appropriately, bake things correctly. So now, yeah, Xavier, if you bake, then yeah, you probably know cups and quarts and all that, or if you just cook for yourself. Do I cook for myself? Well, sometimes. My girlfriend also cooks for us because she's a lot better at it than I am. But if ever she's busy off doing something and it's time for me to make dinner and we have ingredients in the kitchen to make dinner and just have to put them all together, I'm going to Taco Bell. All right, that's how it's going to work. I'm going to give me a quesadilla and a quesarito and a 5-layer burrito. And yeah, you definitely, if you're working at a restaurant, you're definitely going to have to make snap conversions. You're going to have to do them either in your head, get a ballpark. Of course, cooking food is also a bit of an art. It's not just a science. So I kind of like that about cooking and preparing food. Does that mean I'm good at it? No. I can handle the science part of it. I can't handle the art part of it, where you kind of base things on your own experience. And so I'll burn it or it just won't come out right. And I'll use all the same ingredients and all the correct procedure. And I'm just wrong. See, there's a little bit of art to cooking. And that's why most of my diet consists of Taco Bell. And again, I've made this joke 40 times before, and I'm going to make it 40 times again. Am I being paid by Taco Bell to say that their food is amazing and delicious? Yes, there's a giant truckload of 5-layer burritos they're ready to dump off into my backyard, and I will have years and years and years worth of 5-layer burritos. So let that be a lesson to you, kids. I don't know what that lesson would be. So anyways, there's actually a big difference between weight and mass. Weight measures not just how much of you there is, it actually measures how much gravitational pull there is on an object. Whereas mass simply measures the quantity of matter in the object, determined basically by its molecular structure and how many of those molecules there are in that object. So we won't go into uber detail about this. It's a fun little distinction. But on planet Earth, we're not going to worry about the distinction so much as long as we understand we're staying on Earth. Because Earth actually has, for the most part, on its surface, a constant gravitational pull on everything. So it doesn't really matter if you change places on Earth, your weight doesn't change just because you moved. However, if you were to go to the moon, your weight would, if somehow Dr. Manhattan teleported you to the moon right now, and so boom, you're on the moon, your mass is not going to change, not immediately, because the total amount of you there is, the total amount of physical matter, a number of molecules and all that of you didn't change, but your weight actually will change because the moon has a different gravitational pull than planet Earth does. So that's kind of an interesting idea, the difference between weight and mass. However, we're going to pretend they're basically the same thing, even though they're not, and just use the word weight and not overthink it. So in the English system, We use all kinds of things. We use pounds, ounces, tons. 1 ton is 2,000 pounds. 16 ounces is 1 pound. This is not the same as a fluid ounce. This is an ounce that is measuring weight. Fluid ounces measure volume. So there's 16 ounces to a pound. Most of us measure our weight in pounds. I think anyone who is American, who's from America, currently lives in America, and tries to tell everyone their weight in kilograms, doesn't that sound a little bit pretentious? You know, oh, I did a study abroad in England. Okay, well, just call it pounds here. We're in America, okay? You can call it pounds. You don't have to. It's not required, but it just seems a little bit, I don't know, pretentious. But maybe I'm wrong. So those are our units of weight here in America. In the metric system, of course, they use the King Henry Dyed system, but that's just your system of prefixes. The base unit is called the gram. It's called the gram. And there's an Instagram joke to be made here, but actually TikTok has completely surpassed Instagram probably. So no, never mind. We're not going to make that joke. So anywho, in the metric system, again, we would just use our King Henry Dyed system. And it actually doesn't matter. The prefixes are exactly the same. It's just you're talking about a different base unit now, but the conversions between them runs the same. No difference. We can also make a few exchanges between the volume and weight of water. So if you're talking about water, this is actually important because this is how we define certain things in the sciences. We're not going to go into uber detail about it. But basically 1 kilogram of water, where a kilogram is amount of weight, is 1 liter of water. That's a base definition. That's not going to be the same for Mountain Dew because Mountain Dew is a different substance. 1 kilogram of Mountain Dew may take up more than a liter. In fact, I think it would because I believe it would be denser than water. So, or no, it would take up less space then. In that case, if it was less dense than water, it would take up more space to have the same weight. It's a little bit confusing, but this is just applied to water. We won't go into super detail about this. But now some of the important distinctions or the important measurement differences. 1 ounce in English units, in the units we use here in America, is about equal to 28 grams. So if you want to get an idea of how much a gram is, 28 times 16, 1 pound is 448 grams. So, you know, if you weigh 200 pounds or if you weigh 150 pounds, that would seem like a lot of grams. So a 200-pound person is going to weigh 89,600 grams. So just kind of interesting, 89.6 kilograms. You can do the straight conversion between pounds and kilograms as well. Again, all the base conversions you need are going to be available to you. So if we want to convert 160 pounds to kilograms, we need to know some of these. Since we're going from pounds to kilograms, we want pounds to be on bottom of the unit fraction and kilograms to be on top so that pounds cancel out. So this is the unit fraction we'd want to use, 0.45 kilograms per 1 pound. So 160 pounds, we multiply that times 1.45 kilograms per 1 pound. Pounds cancel out. So bada bing, bada boom. You're left with kilograms as your only unit. You still have to do the 160 times 0.45, which will give you 72 kilograms. So some interesting stuff in here. Nothing too wild. The last leg here of chapter 9, we're going to talk about temperature. There's going to be two scales of temperature that we will concern ourselves with, Fahrenheit and Celsius. Fahrenheit and Celsius. Fahrenheit is, of course, what we use here in the United States. Celsius is what is used through most of the rest of the world. In America, water freezes at 32 degrees. So that's why we say it's free, like we literally say it's freezing whenever a temperature is 32 degrees or below in Fahrenheit. In turn, water boils at 212 degrees, which is pretty hot. Don't touch boiling water because it's at least 212 degrees hot, which you don't want to get anywhere near that. In Celsius, it's convenient because the water freezes at zero, exactly zero, and boils at exactly 100 degrees Celsius. There's good and bad reasons to use Celsius. There's good and bad reasons to use Fahrenheit. Now, you might think the metric system is more convenient because all we have to do is move decimal points in order to make conversions between things in the metric system. And so we all pat ourselves in the back and say, why don't we switch to the metric system? I actually have a good reason why we should not move to the metric system here in the US. And it's because, let's say you were a nurse at a hospital and you were giving doses of medications to someone. If you give a person too much medication, depending on what it is, you could kill that person straight up. And if that happens, obviously someone died, which is terrible. And I'm sure we all have had stories where we know someone who got an incorrect dose of something. B, if someone dies under your care, you will most likely lose your job. You could be held for criminal negligence. You may even spend time in prison for it. So it's very important not to make a mistake when you're giving someone medication because there's horrible, horrible consequences. Imagine if you are a nurse. Well, in the US, if you had to do all these conversions, we actually use the metric system in hospitals in the US. But let's say they didn't. Let's say they used, instead of grams and all that, let's say they tried to use pounds and ounces for weight, or fluid ounces they tried to use for volume, and you had to make all these wild conversions that you couldn't do on the top of your head. You're actually less likely to make a mistake because you're kind of forced to bust out the calculator and to take a second extra time to think about what you're doing. If you had metric system, you can easily make conversions by moving decimal points. What if you move the decimal point one place too far? You could give someone 10, 100, 1,000 times the required dose. If you give someone 1,000 times the required amount of morphine or something they use for pain, you are going to kill that person. With the US system, you actually might have to think about it a little bit more, spend a little extra time, and be a little extra careful. And so that's actually why the metric system is great for a lot of things. There's a lot of times when we want to make it easy to convert, but I think if it's easier to convert, it's easier to also make a mistake because of how quickly we try to just do it in our heads. So there's reasons not to switch to the metric system, although in most hospitals they are using the metric system anyways. There's also another famous temperature in Fahrenheit. You probably know what this is. 451 degrees Fahrenheit is actually very famous. There's a Ray Bradbury novel that we were probably all forced to read in high school called Fahrenheit 451. Now, you're forced to read it in high school, so you probably think it sucks, right? You're like, well, if you have to read it, it's not very good. That's actually not true. It's a fantastic book. It's just that whenever you're forced to read it, you just naturally don't want to. You want to, I don't know, fight the power or something, be a rebel. And 451 degrees Fahrenheit is the temperature at which paper burns. And so that book is actually about, or that novel is about burning books and the idea of censoring and suppressing information. So it's a great book. Anywho, if you want to convert between Celsius and Fahrenheit, Celsius and Fahrenheit, you would use one of these two formulas based on what you're starting with. If you're starting with Celsius, you would use this formula so you could plug the Celsius value in and then get Fahrenheit out of it. It turns out, though, on your formula sheet, you're only going to get one of these two, either this one or this one. You can look at the formula sheet before you start the exam. It'll open on the day of the exam on Thursday. You're only going to get one of them because really, let's say you were given Celsius, but this is the only formula you have. You could still plug in your Celsius temperature and then solve for F. Multiply both sides by 9/5 and then add 32 in order to get F by itself. We should be awfully comfortable with linear solving at this point. So you're only going to get one of these two formulas. So let's say the bills from your European vacation, I think that's probably a Chevy Chase reference. If you don't know what I'm referencing, that's okay. I reference a lot of things that nobody cares about anymore. Anyways, you decide to take your temperature, and you have a temperature of 37 degrees Celsius. So your temperature gauge, your thermometer, is broken and it's only giving you things in Celsius. I have no idea whether 37 degrees Celsius is bad or good. So I'm going to have to convert from Celsius to Fahrenheit. I can use this formula. 37 is my temperature in Celsius. So I'm going to do 9/5 times 37. Do that first. You'll get 66.6, the devil's number. Then you add 32 to it. You end up with 98.6 degrees Fahrenheit. So if you're running a 37 degrees Celsius temperature, should you call the hospital? Do you think you might have COVID? Do you need to get a test? In this case, well, if you have other symptoms of COVID, go get a test. But this is not one of them. You're not running a fever. Anything under 100 is generally considered not running a fever. You also need to take multiple measurements. Don't just do it once because there's all kinds of factors. Do it a couple times and see if you consistently have a high temperature. Then you might actually have a fever. If you want to convert from Fahrenheit to Celsius, you would technically use this other formula, but if it's not given to you, you can still go back and use the original formula. Plug in what you have. If you have a Fahrenheit temperature that you're given and you want to convert it to Celsius, and this is the only formula you have available, plug in your Fahrenheit temperature and solve for Celsius. There you need to subtract 32 first, then multiply both sides by 5/9, the reciprocal. But you can convert between those two temperature scales using the appropriate formula. The last temperature scale, the Kelvin scale. The Kelvin scale is just 273 degrees, 273.15 degrees more than Celsius. That's all it is. 0 degrees Kelvin is considered absolute zero, the very, very lowest temperature that's possible. At the end of the day, what temperature is it's the measure of the velocity that the particles in a given substance are hitting against the boundaries of that substance. So whenever it's a higher temperature, particles in the air are actually technically moving faster. Temperature and energy are very, very closely related. If something's moving faster, it requires more energy. We won't go into that level, but if something is absolute zero, that means it has no temperature and nothing's moving. Even frozen water, completely frozen water, is not absolute zero. It's nowhere close to it, actually. Frozen water, the particles in the water particles are still moving around, and they're still moving a lot faster than you'd think. They have just reformed themselves to make a frozen shape. It can be argued that there's nowhere on planet Earth that is at absolute zero. And it could even theoretically be argued that we can never actually reach absolute zero and observe it, but it can also be argued that we could. So if you want a very quick, remember Kelvin is always 273.15 degrees more than Celsius. So absolute zero on the Kelvin scale is zero. That's kind of why the Kelvin scale exists. But then on absolute zero is negative 273.15 degrees Celsius. Absolute zero on the Fahrenheit scale is negative 459.67 degrees Fahrenheit. Water freezes at these temperatures. So 273 degrees Kelvin sounds like it's really a lot, but actually that's when water's freezing, which is actually pretty low. It's pretty cold. So the Kelvin scale it's not used a whole lot around here, but it is used in the sciences a lot more than it would be kind of in your daily life. So that wraps up chapter 9. What I want to do is I want to have a little bit of a review, for chapter 8, because your exam on Thursday covers chapter 8. How is Mr. Gunther going to review? Well, I'm just going to go and pull up some homework problems. So let me pull those up. So what we just talked about, and I accidentally had the recording paused, so I wasn't recording that last part. I apologize. If you're watching this on the YouTube, we're just working some problems from the homework together. You're going to have different numbers, but it should be recording now forward. I swear I hit the play button, but it didn't like it. So those last two, we were talking about just a lump sum of money moved through time. That was section 8.3 and 8.4. Here, if you're talking about something that's section 8.5 related, you're actually talking about an annuity. Well, Josh, what if I'm on the test and I have no idea which section it's over? You're going to need to read the problems carefully. If it's talking about an annuity, if it's talking about saving some money over time and not just a one-time lump sum of money, but you're slowly going to put more interest or more money into an account. So like retirement, I'm going to put $300 a month away for the next 30 years. I'm not just putting a whole bunch of money in at once. I'm putting in a little bit right now, then a month later, I'm putting a little bit more. A month after that, a little bit more. That is called an annuity. It is not the same as a lump sum. So you really have to read these problems carefully so you can choose the appropriate formula. Now here, we're putting a deposit of $8,000 per year away into some account. The formula, this is now going to involve an annuity. The formula is just completely different. It's the payment into the account each time period, and then it's just a kind of an ugly, nasty formula. There's no way to say it other than that. I'm just going to say it. I don't care that you hurt your elbow. I don't know if you've seen that Vine, or if you even know what a Vine is, because they have clearly been replaced by TikToks, but that was a very popular Vine. And if you're looking at me like, do you know what a Vine is? Okay, good. I don't know. I don't know. I don't know if everyone watches Vines. My girlfriend and I, we'll just sit and watch YouTube compilations of Vines. It's funny. I reference that all the time at work. Yeah. It's like, it's just such a funny Vine. I love Vines. They're fun. Yes, I shall. Thank you, because I almost forgot. Not that I ever forget or make any mistakes. I'm infallible. So we're going to be using this formula now for an annuity. Specifically, it's for an annuity where we're looking for the future value. We're looking at how much is going to be this account going to be worth X number of years from now. This is not the same formula as when we're trying to figure out the payment necessary to buy a house or something like that. That uses a different annuity formula. So we have to kind of separate between the two. So here, we want to know how much money will be in an account if I'm putting $8,000 away each year. Don't worry about the end of each year versus beginning of each year. We don't make that distinction in this class. So I'm putting $8,000 a year away for 10 years at 3% interest compounded annually. So using those variables, A is going to be what we don't know. It's going to be the amount that has to be in that account. PMT is going to be the amount we're putting away each year, $8,000. R is going to be the interest rate expressed as a decimal. N is going to be the number of compounding periods per year. Since it's compounded annually, N is just 1 here. T is going to be 10 years. So we have to set it up properly. A equals 8,000 times 1 plus 0.03 over N is 1 raised to the 1 times 10 power minus 1 all over 0.03 over 1. Now, how in the world do you put that mess into the calculator? If you're using sorcery, if you're using magic, what you would do is you would say N is 1 times 10. It's that NT really in our terms. So it's going to be 10 there. The interest rate is going to be 3%. The PV is going to be 0 because we're assuming the account starts off with nothing in it. The payment is going to be 8,000. The future value is going to be what we're solving for. I over Y and or P over Y and C over Y will be 1 each. Then you can solve for the future value there. If you're not using witchcraft or sorcery, you can kind of put it in like this, although let me type it fully out because it's a little bit nightmarish if we're being completely honest with ourselves. So give me a moment to get all that out. And yeah, it's a nightmare. That should take care of it for you, the number of parentheses and everything. Again, the parentheses may be excessive. It's hard to say. You're going to have to find a way to get comfortable with your calculator. Talk to it. Your calculator has feelings, and if it doesn't, there will be a model someday that does have feelings. Your calculator one day will have feelings. You know, you may need to just upgrade the RAM, and boom. You're going to end up with $91,711.03 in there. So that would be the answer to this one, 91,000, assuming I didn't make any mistakes, which perhaps I did make a mistake. Hold on, let me double check. 3% compounded annually, 10 years, $8,000 at the end of the year. Use the appropriate value to find the value of the annuity. Did I not put a comma in there? Hold on, maybe I just made a computation mistake, which we're all apt to do. Times 8,000. No, I didn't make a computational mistake. Let's see, did I make an error? Compounded annually, so N is 1, T is 10. This is the correct formula. You know, I might actually just disagree with this one. I did not make a mistake. Well, I did. Round to the nearest dollar. It got me, guys. It got me. I rounded to the nearest cent. So we did literally everything right except at the very end. So round it to the nearest dollar for whatever reason on this problem. Happy polylogies. Now, the amount of interest we earned, we don't just do 91,711 divided by 8,000. No, think about it. We put away $8,000 per year for 10 years. So we subtract off 8,000 times 10, where we do the 8,000 times 10 first. You're going to end up with $11,711. Because you have to think, what if I had not invested that money and gotten a 3% interest rate? What if I just put it in a boring bank account that didn't grow? I'd have ended up putting 80 grand into that account. But since I let it grow, I ended up, in fact, with $91,711, which means by putting it and investing it, I earn $11,711 in interest. So on this homework, you need to use the correct formula, which is this one. Notice that there's no negative exponents anywhere. It's the more complicated formula that does not have negative exponents. Whenever you're calculating the payment on a mortgage or something like that, you will need to use negative exponents, and so that's how you can decide between the formulas. So let me pull up the last homework assignment. Let's work one that involves us finding out some things about a home. Now here we're going to use this formula to calculate the payment. This time though, it has the negative exponent in it, which is what we want. So this is for an annuity where instead of putting money away and saving it, instead you're paying something off over time with constant payments. So it's still an annuity, it's just a different type of annuity. It's theoretically still an annuity. So we'll use this formula. First, the price of the home is $115,000, but the bank is going to require a 20% down payment and 3 points at the time of closing. Let's do some computation. You have a $115,000 home. You require a 20% down payment. So we need to multiply that by 0.2. And I believe that's going to be $23,000. Double check that because I don't trust myself. Yep. So first of all, you got to make a payment of $23,000 right away to buy this home. That's why it's not easy to buy a home, because you already have to walk in with a pretty nice chunk of change there. 23 grand is nothing to sniff at or whatever, sneeze at. Next up, the amount of the mortgage, that's how much you're financing, aka borrowing. This is how much you're financing, aka borrowing. Well, if it's a $115,000 house, you got to pay off $23,000 of it right away. Then the difference between those numbers is how much you have to borrow in order to make it happen. So you need to do $115,000 minus the $23,000 that you already have paid off in your down payment. And so the difference of those things is going to be $92,000. So you need to basically get a home loan for 92 grand, 92,000. Now, what we also find, and I'm going to have to start deleting some of this stuff, you're going to have certain closing costs. Now, the closing costs never come out to, oh, give us 3 points for, that's not how it actually works. What it really is closing involves you paying a few fees here and there. And sometimes we just calculate them as a percent of what you borrow, but that's not really how a lot of closing costs work. What are some of the closing costs? You got to pay to transfer the deed of the house, because someone has to certify it. It has to go through a legal process, lawyers and whatnot. And that technically, if someone's doing you a service, you got to pay them. So the deed transfer costs some money. A lot of the closing costs that they'll incorporate are the amount of money you need to put into escrow, which is a fancy way of saying the amount of money you need to put aside for some of your insurance and taxes that you know you're going to end up owing. What else is the closing costs? You got to pay to inspect the house. It's usually like $350 to $400 for having an inspector out there. More if you want them to inspect for termites. You got to pay for inspection. You got to pay to value the house, meaning you pay the county a fee, usually about $500. And what they do is they go to the house itself. They spend about 10 minutes there looking at it, make sure it hasn't burned down, make sure it still exists. And then they go and compare other houses in that neighborhood, how much they were sold for recently, and they decide how much the house you're buying is actually worth. And it turns out if the house you're buying is worth less than what you're paying, your financing company may not like that. They might get mad about that because the whole point is if you can't make payments, they're going to sell the house and get the money back. If the house isn't worth as much as you owe them, they're going to lose money on you. So they usually won't let you. It's really about how much you're financing. Blah, 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 all that to say that buying a house, while it's a great moment in your life, is also a very complicated moment. Definitely you want to work with a realtor. A realtor, while they do charge a fee, a realtor smooths all of this over like you wouldn't believe. So anyways, they want 3 points at closing. What that translates to is the bank or whoever you're financing through wants 3% of the mortgage amount as an upfront fee, although it's not really a fee just to them. It's a fee to cover things. It's not just they're greedy. It's a fee to cover actual things that need to happen whenever you buy a house. So don't think of it as, oh, they're just trying to steal my money. That's really not entirely the case. So we take 92,000. We take 3% of it, so we multiply it by 0.03. And do I feel like doing that in my head? Maybe it's 2760. I'm going to double check that. Ooh, I'm good. So it'll be $2,760. Now the monthly payment. So all of this was just the preamble. Now the monthly payment. Now we got to use this formula here. We have 5 variables in that formula. You have PMT. That's what you don't know. That's what you're solving for. P is the present value or the amount of house that we're financing. That's not $115,000 because we're not borrowing $115,000. We're borrowing $92,000. R, the interest rate, it straight up tells us the interest rate is 8.5% or 0.085. That's kind of a high interest rate right now. You can get a lot better interest rate, you know, if you have good credit and make a certain income, you can get a much better interest rate than 8.5%, but it just depends. N is going to be the number of compounding periods per year. We're going to assume that we're making monthly payments on this. It's automatic. It doesn't even say monthly in there, but it's just implied. Well, no, never mind. It does say. It says monthly payment. So when it says excluding escrow, taxes, and insurance, basically it just says ignore any of the other factors. Just the 92,000 is what you're looking at. T equals, this is going to be a 30-year mortgage. So T is 30 years. Using your witchcraft, N is going to be 30 times 12. 360, because you're making 360 total payments on this house. Interest is going to be 8.5%. P is going to be how much you're borrowing, the 92,000. PMT is going to be what you're solving for. The future value, FV, is going to be 0 because in 30 years, you're going to have paid off the house. And then P over Y and C over Y will both be 12 because you're making monthly payments. But using the formula, and you know, it's a doozy. You can do P 92,000 times 0.085 over 12. All of that over this nastiness. And we're raising it to a negative exponent here. This is negative 12 times 30 here. Whoa, that is heavy. So you're going to need to find your way of getting comfy, getting comfortable with putting things into your calculator. There's just no other way to explain it than that. So let me do this computation. And we're going to end up with a payment of about $707.40. Now it wants us to round to the nearest dollar. I won't make that mistake twice. So we round it to 707. And finally, the total interest we paid over the months, over the years. Think about it. We made payments of $707 every single month for 30 years. So, blah, blah, blah. You're off by a factor of 10. So check your PV and make sure you put 92,000 and not 9,200. Was that it? Yeah. Easy mistake to make. So now we're doing $707 a month times 12 months a year times 30 for 30 total years. So in total, we paid out of our own pocket $254,520 in order to pay off a $92,000 loan. That's basically how we're going to see it. We're ignoring the down payment we've already made. So technically we made a payment of, we've paid $274,520 or whatever with the down payment added in. We're going to ignore that. We're just going to say we've made payments of $254,520 in order to pay off a $92,000 loan, which means that the amount of interest we paid is $162,520. That's a lot. The reason we don't include the down payment in this calculation is because we didn't pay any interest in order to make the down payment. The down payment happened before we financed or had any interest accrued. And now if it says this is wrong, it's going to be because it didn't want me to round to 707. Nope, it likes it. So similar problems will work for car ownership. You make a down payment on a car, you finance the rest. You probably won't finance it for 30 years. You might do 5, 6, or 7 years, maybe 4 years, maybe 3 years. You're going to pay a lot less interest on a car loan than you would on a home loan, because 30 years on a home loan is just a long time for interest to accrue, and it's really going to start stacking up. Okay, I've taken attendance. Everyone is good to go. Good luck. Remember, we're not meeting on Thursday because Thursday is your Chapter 8 exam. You'll find it on MyLabs Plus. You'll find the instructions in a Canvas module, just like for the last exam. We will be using the HonorLock system. So make sure you read the instructions carefully. If you have any technical issues, I would love to help you, but there's some that I have no way to help you on because I'm just not an IT professional. You'll want to reach out to the HonorLock people using their chat feature. When you go into HonorLock on Canvas, you should see it, and they can help you out there. Unfortunately, there's very little I can do on the IT side. So good luck on your exam Thursday, and y'all have a great day.